Unfortunately, I am not able to join you guys today, but you guys are lucky and you guys get to listen to me give you guys your notes today. We are going to have to go pretty quick. I only am allowed 15 minutes on this video, so we're going to have to try to keep up. There's going to be some things that you'll have to fill in the gaps. This video will be posted to our Edmodo site as well, so you'll be able to go back and try to catch up with that. We have 4 goals to get through, so there's some examples that I will do and then some try problems that you guys will be expected to complete, and the sub will have the answer key so you can check the answers with our sub today as well. So, getting right into it, we have these 4 goals. We're going to be able to identify the converse of a statement, the inverse of a statement, the contrapositive of a statement, and then create biconditional statements. In order to do this, we are going to need some vocabulary, and most importantly, this idea of negating or negation of a statement. Yesterday we talked about making statements in a hypothesis. When we're negating that, we're saying the opposite, or not that statement. In symbols, we would use this little tilde and say not P. For example, the negation of it is raining, or R, is it is not raining, or not R. So when we continue to talk about negation, I'm going to use those symbols, especially since we're on short time. Getting right into exactly what these statements are. If our conditional statement is if P then Q, and I want the inverse of that statement, I negate the conditional statement. So the whole statement will be negated, which means I would have to negate my hypothesis, so not P, and at the same time negate my conclusion, not Q. I would read that as not P, then not Q. The converse is a little bit different. This time I reverse the conditional. I don't need to negate anything. I keep P and Q, I just switch their order. Instead of if P then Q, it's if Q, then P. My conclusion becomes my hypothesis, and my hypothesis becomes my conclusion. The contrapositive then takes the converse and negates it. Just like the inverse negated the conditional, I now have not Q, then not P. Let's take a look at an example of this. We are going to spend some time talking about whether these statements are true or false, but we're going to wait until we get to the end, so we can ignore these true or false for now. My conditional statement says, if it is raining, then I will use an umbrella. In symbols, I might say R, then U. The inverse will negate both of those sentences, both of those statements. So instead of R, then Q, it'll be not R, then not Q. And the whole idea is I'm only adding the word not. So instead of if it is raining outside, I have if it is not raining outside. Then, instead of I will use an umbrella, it's I will not use an umbrella. So the whole key to the inverse is we keep the order the same and we add the word not to the hypothesis and the conclusion. The converse, I don't add any words. I switch my hypothesis and conclusion. So instead of not R, then not U, it's U, then R. So if I use an umbrella, then it is raining. So I don't use the word not at all. The contrapositive works off of our converse. So if my contrapositive is the negation of my converse, I'm going to use the word not again, but keep it as U then R with the word not. So if I do not use an umbrella, then it is not raining. Again, I've added the word not to both the hypothesis and conclusion. The next part, I'm just going to do part A with you guys. You're going to be in charge of the rest. This is a statement. I have to first make it a conditional statement, so I have to put it in if-then form. The statement says that all right angles are congruent. So I need to say that if two angles, first of all, there's two pieces of information. One is that they're right angles, the other is that they're congruent. One becomes hypothesis, one becomes conclusion. So if two angles are right angles, then they are congruent. If two angles are right angles, then they are congruent. Your job, when we're done taking these notes, is to go back and fill in parts B, C, and D based on our rules for inverse, converse, and contrapositive. For now, we're going to flip to the next side and introduce goal 8. And we're going to create biconditional statements. So if my statement is that two lines are perpendicular, intersect to form right angles, I again have two pieces of information. First, two lines are perpendicular. Second, they intersect to form right angles. One becomes my hypothesis, the other becomes my conclusion. I always take the first one as my hypothesis. So two lines are perpendicular. That's my symbol for perpendicular. Then my second piece of information is my conclusion. They intersect. We must have that to form right angles. Recall that the converse is the only one that we do not negate anything. That's the one where we don't include the word not. We simply flip our hypothesis and conclusion. So my new hypothesis would become intersecting to form right angles. But I can't use the word they because I haven't introduced what they are yet. So I again have to include the words two lines. So if two lines intersect to form right angles, then I can use the word they again now. They are perpendicular. So like I said on the front, we do need to be able to look back at these and identify whether the statements are true or false. So if I have two lines that are perpendicular, are they always intersecting to form right angles? The answer is yes. So my conditional statement is true. By definition, two lines that are perpendicular form right angles. Then I have to ask the same question about the converse. If two lines intersect and form right angles, are those lines perpendicular? And again, that's true. That definition works both ways. So the conditional statement and the converse are both true statements. When this occurs, when they're both true, only conditional and converse, we have a biconditional statement. When we have a biconditional statement, we use the phrase if and only if. We're going to replace our if-then with if and only if, and it'll go in the middle. Here's an example of that. Assuming that these are both true statements, if I am not at school, then it is Saturday or Sunday. If it is Saturday or Sunday, then I am not at school. That's a conditional and it's converse. I'm going to take my hypothesis and my conclusion and rewrite them I'm not going to need the words if or then anymore. I am replacing those two words with if and only if. So my hypothesis, if I am not at school. But do I need the word if? No, we said we're getting rid of that word. So I'm just going to say, I am not at school. I'm going to then include the words if and only if. I'm forgetting the word then and saying it is Saturday or Sunday. All right, your job will be to finish our try problem here. We've got a few more examples to get through. The next example, I'm going to take a current biconditional statement and write it as a conditional and its converse. In order to do that, I identify where if and only if is. That's the part that's separating our hypothesis from conclusion. So I know it's going to be an if-then statement. I can now take the first part and make it my conditional, my hypothesis, the second part, and make it my conclusion. So if 3 lines are coplanar, then they lie in the same plane. And then my converse, I would switch those. If 3 lines lie in the same plane, then they are coplanar. Your job will be to finish the try problem for that example as well. All right, we are on to our last page. We have 2 different types of things that we need to talk about. First, we're going to be able to identify whether a statement is a biconditional statement or not. We're going to do the same thing. So find the conditional, find its converse. Here, x equals 3 if and only if x squared equals 9. Well, if x equals 3, then x squared equals 9. The converse, I switch the order. If x squared equals 9, then x equals 3. Is it a biconditional statement? Well, remember, for it to be biconditional, both have to be true. In this case, if I know x is 3, does that mean x squared equals 9? Well, the answer to that is yes, so my conditional is true. But if x squared equals 9, does that mean x is 3? And the answer to that is false. So we can say that this is no. While x might equal 3, I can come up with a counterexample. If x squared is 9, then x could equal -3, which would mean that this is false. So this is not a biconditional statement. The last examples I want to go through are at the bottom here. You guys are going to do this try problem. Here, all we're doing is finding the converse and either writing the biconditional if it is true, or writing in counterexample if it is not. So if 2 planes intersect, they contain the same line. If 2 planes contain the same line, then they intersect. Well, that's true. If 2 planes contain the same line, then they definitely intersect. So I would write the biconditional with if and only if. You can't take this shortcut I am because I'm running out of time. You would have to fill those in. Now the last one, if a number ends in 0, then it is divisible by 5. Well, its converse, if a number is divisible by 5, then it ends in 0, is not true.